So I don't know how I could possibly follow Sandy Metz. Oof. I was nervous about that even before I knew what she was going to talk about. So my name is John, and I'm an engineering director at W&R Studios. We make products for real estate, which we're doing the best we can. So I actually live about 20 minutes south of here in Franklin, and I moved here a couple years ago. And I know it's like the last day of the conference, but if you haven't been down there to check it out, it's pretty cool, super old, lots of good stuff to eat and see. They have the best ice cream in the whole wide world right on Main Street. And this ice cream is so good it can cause you to make bad decisions, but we'll talk about that in a little bit. So I'm gonna tell you a story about how many small decisions over months of time created a catastrophe that we basically couldn't recover from. And we lost 50 million of our records. So first, we need to set the table. There's a lot going on in any system. This is no different. So because we're in real estate, I need to kind of talk to you about some terms that I'm going to be using. So an MLS, for our purposes today, is just an organization that collects and distributes listing data. A listing is like a property for sale. An agent is a licensed real estate agent. These are who our customers are. And a listing is a record that is like an ad for a property, essentially. If you go on Zillow, click on a house, that's a listing. And a data feed is just an API that's offered by an MLS to provide listings for us, for really any software vendor. So this is our kind of landing page. We have 4 different products that work together as like a suite. And we provide, here's like one particular example, just a tool for agents to search listings and quickly and easily. So here's like a listing detail page. You can see there's like a lot of data. A typical listing record has 300 to 400 fields, and they can have upwards of 1,000 fields in some cases, which causes all kinds of problems. And then a lot of people think that there's like one MLS in the United States. There's actually more, like 700. And here's like a map of all the places that we pull listing data from currently. So there's a lot going on. In order to gain access to each of these MLSs, we have to jump through all kinds of hoops. We have to do demos and wait for sales cycles, get board approval, contract sign. This can take weeks or months, and it's taken us years to get to this point. So we have all these products, we have all these data feeds, and all of these products use this listing data in some way, but it's all kind of a nightmare to deal with. So we need something internally that manages all of this. So we built something we call Forge. I watch a lot of YouTube videos. There's a guy who makes things out of metal. I thought, well, that's kind of what we do to this data, is heat it up and beat it with a hammer until it's in the shape that we want it to be. So it's a Ruby app, and basically its job is ETL. And currently, today, there's like over 60 million records in this thing. It's an Elasticsearch cluster, and we have about 500,000 licensed users across all 4 products. It's a big challenge, lots of data, lots going on. So I'm gonna kind of break down into exactly why it's challenging. So extraction first. Each pin represents a particular API that we have to pull data from. Managing the configuration for hundreds of APIs is kind of a nightmare. You would not believe how many options there are. And this is obviously creating lots of problems for us. The next thing is that there is a lack of speed in these APIs. Here's an example. Here's an actual screenshot of the product where it shows we pulled 1.6 million records over 7 days from this API, which works out to about 150 records a minute. That's about as fast as we can pull data from reliably. So that's really, really slow. So to sum up extraction problems, hundreds of API configurations, permissioning and licensing, they're extremely slow, and it's changing all the time. There's new standards, we have to account for that. Okay, so what about transformation? Transformation is actually probably the hardest thing that we do because this data is weird, you guys. It's super weird. Here's two quick examples. This is a very small portion of a listing record from two different sources. So you can see the thing on the left kind of makes sense. The thing on the right makes absolutely no sense. And it's someone's job to go sift through all of that and make sense of it hundreds of different times. When you consider that a listing record is like 400 to 500 fields, you can see that very error prone. We make mistakes. We have to fix them all the time. Then there's other problems that just break all the rules. Well, whatever you think this is, you're wrong, because that's what it actually means. Right? So, transformation is hard because field names are totally different per feed. We have conventions that defy all reason and logic. We also have extremely opinionated customers. If they don't see the data that they want to see in the format they want to see it, our product is unusable to them. It's difficult to get feedback, and this data changes on the regular. I mean, monthly, they change something, they rename something, they add new options, they take options away. All kinds of stuff. Okay, so loading the data. Most of the issues we deal with loading are all around Elasticsearch. Elasticsearch is a really, really awesome product. It is black magic, almost. But there's two, and if you're not familiar with Elasticsearch, that's totally fine. There's two really important things you have to know about it. First of all, if you try to put records into an index that doesn't exist already, Elasticsearch will create one for you, which is cool. But mixed with something called dynamic schema, so from their documentation, by default, fields can be added dynamically to a document or to inner objects within a document just by indexing a document containing the new field. So in this mode, Elasticsearch analyzes the data you're trying to give it and generates a schema for you based on the value. So this is cool in a demo, but in a production scenario, you never want this to happen. Trust me. So we go to great lengths to avoid that. So loading is, Elasticsearch is awesome, but it's a huge system. There's a lot of things to know about. And there's some definite things to watch out for in production. Okay. We're almost through the setting the table stage, I promise. Okay, so we had to build this thing that we called Forge. So the very first version of it, we had YAML API configs. So remember, we have to handle all of that configuration. We thought, well, this is the simplest thing that can work. This works. YAML Elasticsearch configuration, static data mapping classes. So you literally, writing a Ruby class that knows how to translate data from one particular API into a format we can use. And we didn't think to store a local, raw, unmapped copy of the data. So the entire ETL cycle happened all at once. We would pull it from the API, transform it, shove it into Elasticsearch, everything's cool. So there was also no real staging environment that we could do because we didn't want to be pulling this data multiple different times. So that's something. So this created some problems, and we had to we wanted to fix it because we couldn't iterate fast enough, and we couldn't fix mistakes fast enough because everything required deployment, and it was hard to manage all these things. So we created a dynamic API config. We brought in active record and started doing all of this stuff there. dynamic Elasticsearch config, dynamic mapping system, where you could just flick some switches and everything was fine. Still no local raw unmapped copy, though. And so this was great, but this was built in the same system. And so our API wrappers for handling the connections to the external APIs, handling the connections to Elasticsearch, those worked whether you gave it the YAML configuration or the dynamic configuration. Cool, didn't have to rebuild all of that work. But the data structure was not backwards compatible. The actual output into Elasticsearch was drastically different between the two versions, which meant we couldn't just automatically migrate everything, which also meant that we never have actually fully migrated the entire system. So we were kind of living with this. Most of the things were on this new thing, some of the things we deemed not worth it, which led to like a weird status quo for us. Both versions were in use. The test suite was never updated because all of the API wrappers still worked, whether you were giving it the dynamic configuration or the YAML configuration. And this, about a year later, we still had like 5 YAML configurations left that we just deemed too important to change or not worth it to change. And basically, that legacy system went ignored and forgotten. One day I get this message in Slack. Hey, when I remove this YAML file, all the tests fail. What should I do? So in my infinite wisdom, I'm sure it'll be fine. So that decision, I never would have known this. It put us on a collision course with disaster. We wouldn't know for months that it did that, but it did. So let me explain how you can ruin any application. So fundamentally, or the first thing to do is decide you need to make a change, which happens. This can be a small change, big change, whatever. Then you ignore the test suite because you think that, well, it's okay, or the new thing doesn't really change the test, like it's okay to leave them. Then you're in this situation where you have like this weird status quo where like things aren't really the way you want them to be, but it's really hard to figure out how to change them, or it seems like too expensive or too time-consuming or whatever. So then you have like these problems that arise because of your poor status quo, and you do like these quick fixes. You're not really researching the problem to its depth. You're just sort of guessing, right? Which enough guesses leads to a last-ditch effort to solve some problem. And when you make that last-ditch effort, you have the potential to end in catastrophic failure. Okay, so how did we do this? Okay, so we created this new version inside. We reused the tests, we just left them in there. We never fully migrated, so we had this like weird status quo where we were just living in 2 versions. And like, the quick fixes that we started to make because of this were slow, over months and months. And at some point, our Elasticsearch cluster was running out of disk space. And so I went in, as I normally do, on the server and manually deleted some Elasticsearch indexes that I was pretty sure we weren't using. But that didn't fix the slowness problem that we had been incurring over months. We noticed like weird errors where by the time one of the other systems tried to access a listing, it wasn't in there yet, and that didn't make any sense because Elasticsearch refreshes its like queue to index things every second. So it didn't make sense that that wasn't happening, and so it was getting slower. So we said, let's upgrade Elasticsearch. I'm sure that will fix the problem. So it's not a secret as to what happened after that. So Robert, who's sitting here in the front row, said to me, hey, it's saying there's only 4 million listings in there now. To which I said, I'm sure it'll be fine in the morning. It's late. I'm going to get some ice cream. Remember that? It's that good, I promise you. So, of course, this wasn't better in the morning, right? We had lost 50 million listings. They were gone. And for all the reasons I explained before, we couldn't easily get them back. We couldn't just start from the beginning. It would take weeks to pull all that data again. But what actually happened? All we did was upgrade Elasticsearch, and when it came back online, all of the data was gone. Here's a subset of part of the data that we actually store in Elasticsearch. Anything interesting about this? See these guys? So these are timestamp field names in JSON. I'm sure we can all agree that it's a bad idea to do this, but this is what crashed our Elasticsearch cluster. We made this decision before we even started using Elasticsearch to make it this format. And that decision was our undoing a year later. Okay, so what actually happened? We lost 50 million listings. So remember, I deleted some of these indices that I was pretty sure we weren't using, which we were using. And remember this dynamic schema thing, right? So what I had done was created a situation where the system then tried to index a document into an index that didn't exist, which Elasticsearch happily recreated with dynamic schemas, which weren't ignoring those timestamp fields anymore. And so every time we indexed a listing, many hundreds of thousands of times per day, it was adding a new field to the schema for those timestamps. So every time Elasticsearch was like, cool, a new field. So day after day, this is happening, and over the course of several months, these schemas were like megabytes of JSON, right? And every time a new record was being indexed, it would realize that the schema had changed and then publish it to the rest of the cluster. And so you've got 11 Elasticsearch servers constantly passing megabytes of data just to stay in sync with each other. So duh, everything's really slow, right? Because Elasticsearch can't keep up with itself. So in our attempt to fix the slowness, we added more nodes first, which didn't solve the problem. And then eventually we tried upgrading Elasticsearch. And because of the weird state that it was in, that it never should have been in, that Elasticsearch is not designed to be in, catastrophic failure. So the next morning after I had gotten my ice cream, and I remember talking to my friend when I was getting ice cream, he said, how's work going? And I said, well, to be honest, either tomorrow's going to be the worst day of my job so far, or it'll be just like any other day. It was pretty bad. We couldn't get the data back. It would take weeks. And so we decided to restore from our backups, which took all day, right? When you've got terabytes of data to restore, took all day. Also, once the backups were up, we were in the same spot we were in before we tried to upgrade. Things were fundamentally broken. These giant schemas were still in there. So we had to actually fix the problem the right way, right? We had to declare bankruptcy on those tests that were causing the problem. We had to get rid of all those YAML files that were in there. We had to get the system back up to snuff and make sure that our Elasticsearch settings were back to where they were. It took a couple days, and we were back to normal, and our customers weren't yelling at us anymore. So what can we learn? The first thing is how to handle catastrophe in your organization. There's a running joke at my company that our CTO is like so zen all the time that it's kind of scary. Super helpful in this scenario. You have to stay calm. Yelling at people won't make the problem go away. Yelling at yourself, being mad, crying, it's tempting to do all of that stuff. But it's super important to remain clear-headed and move toward a solution instead of being angry at what happened. The second is you have to actually work the problem. One of my favorite quotes from Apollo 13 is when the mission director says, "Let's work the problem, people, not make things worse by guessing." Because when you guess, you're just grabbing at straws. You have no idea what's going to happen. We were guessing that upgrading Elasticsearch would fix our problem, but it for sure didn't. And this should go without saying, but please, please, please have backups. You can end your whole business without backups. Right? Okay. How can we just avoid catastrophe in the first place, please? So, first of all, you have to take responsibility for the things you work on. You have to take ownership over the projects that you're in charge of or that you work on. Not only will these projects benefit from that, but I promise your career will benefit from it as well. Viewing things as someone else's problem will never get you very far. I've done this, just to be safe. Another simple thing is follow best practices. Most of our systems are are really just some layer that's organizing many, many, many other subsystems. This system was organizing all these API connections, Postgres, Elasticsearch, providing an API, all of these things. Elasticsearch says over and over and over in its documentation, don't use Elasticsearch as your primary data store. We ignored that and thought we knew better, but we didn't. And so many pieces of Elasticsearch, the solution is re-index, which we couldn't do because our data was too slow. And then you have to investigate root causes for things. If you get a weird error that doesn't seem right, and then you just try to swing at it with whatever comes to mind first, like you're gonna have a bad time. Maybe it'll work out, and sometimes it does, and that's even more dangerous because then you believe that you knew what you were doing. So, this was like 2 years ago. So, let's talk about how we fixed it. So Forge 2.0. It was a whole new project. I said, forget this thing. It has all these fundamental problems. It totally bit us. I'm angry at it. I don't want this code anymore. So a whole new project. With the intent of, we need to store this data locally, right? This data is so slow for us to get, but there's so much of it. We argued back and forth about whether we should do this or not, and we decided, yeah, we really should. Proactive alarming, right? Not relying on third party. I'm talking like the system itself emails me every morning about potential problems. And the whole system, as a result, became even more fault tolerant. How do I know this? Because it happened again. Literally 2 months ago. I woke up, I had hundreds of emails from Forge that said, hey, Mongo says that there should be 2 million records, but Elasticsearch says that there's 0 records. So, we lost all the nodes. When we brought it back up, or we lost one node, but when we brought Elasticsearch back up, all this stuff was missing. The great thing is that nobody actually noticed this problem, because I was just able to go into the system, say reindex, 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 100 times. By that afternoon, it was all fixed. No problem. So, final thoughts. I'm super early, so I can take questions if you'd like. Be proactive about issues in your system. They will not go away by themselves. You cannot wish them away. You cannot ignore them. They will grow and get worse. One of my coworkers said to me, we will never use this thing less than we use it right now. We will always use this thing more. There will always be more data in it. There will always be more traffic going to it. So if you're not constantly improving it and fixing these things, you are getting worse. Have a backup plan for unavoidable issues. You cannot prevent your servers from catching on fire randomly. You cannot prevent natural disasters. You cannot prevent these things. And we've dealt with this, as I'm sure everyone in this room has at some point. And you have to have a backup plan. But most problems are completely avoidable. And for those things, we should have a process. We have tests, staging servers, continuous integration, all of these things. But if I ignore those, then what are they there for? Literally last week, I pushed a change that seemed so innocuous, didn't write a test for it, didn't test it on staging, and as the traffic to one of our applications grew on a Friday night, all of a sudden the job queue started spiraling out of control because this thing took 3 seconds in production, but it didn't take that long anywhere else. So I didn't follow the process, and I got bit for it. So I find myself thinking a lot of times, this process or this bug doesn't affect that many people, or it's a super edge case, and I think that allows me to ignore it, and that's just not true. You have to take these things in. So I think that's really it. I hope you can take my story and identify some status quo issues in your own organization, put a plan together, get it fixed, because you don't want to end up in a situation like I was. And thank you very much. What's my dog's name? His name is Nash. He's a golden doodle. I actually just got another one, but he's not in the picture yet. He's too little. Right, so moving forward, how do we prevent this from happening a third time? And recover from it if and when it does happen. We have been really thinking about backup data centers, moving to a data center. Our data center's in Atlanta, which is more prone to natural disasters than we'd like. So that's like one thing. Another thing is just sort of thinking about everything as redundant as possible. Have multiple copies of the thing. Spend the money on more servers if it means you have more copies of your data, so when things go wrong, you can quickly get back. Right, so any development processes that have changed since this happened? I'd like to say yes, but no, not really. I think it's really easy to get into a situation where you have like process theater, where everyone sort of thinks that we're doing a process when everyone's just really kind of doing their own thing. So that's an area I think it's really, really, really hard to follow agile, whatever development process to a T, right? But I think just an understanding of, hey, we have a process and you have to stick to it. There is no change too small that needs to have a test, be tested on staging, and all of these things. And it seems so innocuous, but can lead to such disaster, when you don't follow those things. Okay, thank you very much.